Have you ever wanted to soar higher than a bird or faster than a jet? Have you ever wished that you could fly? Well, if you ever have, there are a couple important details, and some of these come in the form of forces. One of those very important forces is the force of drag.
Let's look at a jet in flight. As you can see in the diagram, there are 4 different forces acting on the jet. The first and most intuitive force is weight. The weight of an object is the force of gravity on the object. So right there we have one force that is pushing against our goal to fly.
For the second force, let's take a look at an example. Have you ever played with a garden hose and you wanted to spray the neighbor cat, your dog, maybe your friend, and so you put your thumb over it? Notice that the water all of a sudden starts coming out really fast. And this is very similar to the principle of lift. The speed of the water that's coming out of the hose is a lot like the air flowing over a wing. With an airplane wing, air travels faster over the top than it does the bottom. This causes a pressure difference, which causes the upward motion that we refer to as lift. Weight and lift are opposing forces. When there's more lift than there is weight, that allows us to go up. To move horizontally in the sky, we now consider the force of thrust and drag.
Thrust is the third force that we're going to look at. Thrust is typically produced by the propeller or engine of an airplane. In the case of a bird, the thrust would be made by energy from the bird wing muscles and flapping.
Last but not least is the force of drag. From the diagram, we can see that drag is an opposing force to thrust. Flying forward happens when there is more thrust than there is drag. We need to know how much drag force to overcome in order to know how much thrust force is necessary for a successful horizontal flight. All right, now let's take a look at the force of drag. Let's consider 2 identical pieces of paper. So I'm going to have Sierra here help me with this little demonstration. And if I crumble up one of the pieces of paper, they're identical pieces. Of course, they weigh the same. Now, if we drop them, which one's going to hit the ground first? 1, 2, 3.
Whee!
Notice that the crumbled up piece of paper fell faster than the non-crumbled up piece of paper. That has to do with, well, the force of drag. The force of drag is a function of the cross-sectional area. And since we have greater area on this piece of paper as opposed to the crumbled up piece of paper, this one's going to fall faster than this one because this piece of paper will have a larger drag coefficient.
The applications of drag force go beyond just flying, some examples being automobiles and swimming. It is difficult to imagine a world without flying, swimming, and driving, yet there are so many more topics that we have not touched upon that incorporate drag. We hope that even though we have not touched upon these conversations, that you can see the importance of drag. Thank you for watching.
Thank you for watching.